Hey everybody, this is Larry. This is day 7 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. And it seems like another easy one. It feels like they haven't had a interesting daily farm in a while, so I don't know. But if you're still here, hit the subscribe button, I suppose. But yeah, let's see, merge sorted away. So given two, I think this is a very standard thing, and actually something that you should probably know how to do in just competitive and in interviews. Yeah, I don't think there's anything that tricky. Yeah, I don't know if this. Oh, I what was there a trickier way to do it? I guess I just know how to do it. I mean, this stuff is part of. I was gonna say this part is kind of in part of merge sort, so it's definitely something that if you're doing divide and conquer, something that you should be familiar with quite a bit. Cool. Let's see. What am I trying to do here, right? I did notice that it was the modified number 1 in place a little bit late because I was trying to look at this input and I see that's why you give an M, because array 1 has M plus N space. Okay, because let's say you don't have. So the idea, I suppose, is to do this in all one space, because if you can do it with, if you don't do it in place, then you can do it in M plus N space, and just like walking the array, right? But okay. But yeah, but I think this is still not that bad of an idea. I think the thing that you might be tempted to do is, and this is what I was tempted to do, so that's why I'm saying it, is that initially you'll be like, okay, let's try to do one digit at a time in the beginning, and then do some kind of shifting thing. There's awkwardness, there's a lot of degenerate cases where you may get into n squared type situation. But then the other thing is to just use the zeros, the padding, more in a way that you only need to write once. And the way that I'm thinking about it is kind of related to what's it called? The flag, the Dutch flag, is that the right flag? I don't know if I'm calling out the right flag, but the Dutch flag algorithm. And it's not really, it's just like maybe it's not quite that, but it's about putting it one at a time. And what I mean by that now is just that the trick here for me is just doing it backwards, right? And what I mean by that is that we start by looking at the biggest number and then fill it out one by one. So then here we go 6, and then we go 5, and then 3. That's from here. You could remove it if you like, but it doesn't really matter because I think it gets overwritten anyway. And then 2, and then another 2, and then 1, right? And then that's basically the idea. And I think from that it should be easy to do. So let's get started then. Let's just say I'm gonna write mn for m plus n maybe as you go to the number of space. Actually, I guess I don't need to do this. This is just m plus n naturally. And I like my fingies to be uppercase, so I'm just going to do it that way. Okay, and then now you go, let's just say m pointer. You can say maybe pointer 1, maybe, I don't know, it doesn't really matter, right? Let's just say pointer 1 that points at nums 1 is equal to m minus 1, right? And then pointer 2 is equal to n minus 1. Both of these referencing the last number, the end of the list, right, effectively. And then now we just do it one pointer at a time. So then now, while num sub 1 pointer of 1 is, we want the greater number, so we have something like this. Or maybe, no, this is a bad while loop, sorry, hang on. So basically, while m is greater than 0 and n is greater than 0, oh no, whoops, pointer 2 is greater than 0 and pointer 1 is greater than 0, because that's the thing that we're moving. Then now we do a check. If this is greater, then, oops. I was thinking initially that I could keep a pointer to the end as well, and we should maybe, I think that's a little bit easier to understand. But that pointer is also just pointer 1 plus pointer 2 plus 1. But we can just go maybe pointer n or something. I don't know. Is equal to m plus n minus 1. And of course, because this is these two minus 1, so that's how we came up with that, or plus 1 rather, sorry. But yeah, but anyway, so then if this is the case, we go yeah, nums1 of pointer n is equal to the bigger number, so nums1 pointer of 1, and then we have pointer 1, oops, you know, subtract by 1, pointer n subtract by 1, and then else we take the else we take it from nums2, so oops, equals nums2 pointer of 2. And of course, you can do some invariant math to make sure, to figure out why this works with respect to that it doesn't overwrite any digit that you haven't looked at yet. That's just an invariant study case, so definitely check that out. Also, hang on, okay, I'm just double sure checking that I'm recording this because I've been keep missing recording. But okay, so then now what there's left to do is just, you know, standard merge sort e stuff. I think technically if pointer 2 is 0, pointer 1 is actually equal to pointer n, but I like to kind of write it like this for whatchamacallit, for symmetry reasons, because that means that and what I mean by that is that code symmetry is important in a sense that I mean, it's not necessarily important, but it makes code more readable, because, and you can actually abstract some of this away because this is a little dry, right? Oops, I actually made a mistake here, so that's good. But what I mean is that, yeah, because you can see that these two code wants to do the same thing, so it should have the same idea, so that if one of them looks weird, you're able to kind of check yourself that way. Where if they don't look the same, then, you know, but technically you can actually just get away with this because, like I said, pointer n should be equal to pointer 1, so you can remove this. But I just want to show it for illustration as well. And then we don't have return, so I think we're done here. So let's give it a spin. Wrong answer, huh? Right answer for the, oh, missing the, that's weird. So this does nothing. This does. So, okay, I see why. The reason is because I made a mistake in my assumption, is because, I mean, this is very natural to write something is greater than 0 because 0 is not a good state. But actually, we would need this to be equal to 0 because we want to, because this is a pointer, not the size. Sometimes I do it with the size, and with the size that would be right because what you're saying and maybe that's a better way of writing it, to be honest, just the size, like size of 1, size of 2, because then this while loop is saying while, I mean, the code is a little bit nuanced, but the difference is saying, you know, between that is that, okay, while the size of the object that we're doing is greater than 0, then we have something to process, right? Well, the thing that I'm writing is if the last character or if the pointer we're pointing at is before 0, then we terminate, right? So there's some nuance in how you express yourself, and I think I got trapped into that a little bit. Good thing that the examples actually test these cases. I was going to test this particular case anyway, because I think that's the tricky edge case of like one item and so forth. I think maybe I guess we could also do one item, which is that we have one item in two things. Right? Could also do the other loop as well, just to kind of be exhaustive. But, or like the other comparison is what I mean. And now I'm going to give it a quick submit. And hopefully that's good. I wonder how I did last time. Cool. What did I do last time? Oh, I did it the same way. Except for I think this is a little bit too clever, but maybe not. I mean, it's the same idea anyway. Anyway, 790 days streak. In terms of complexity, everything's in place, which is for this problem is okay. You know, my long-term viewers or long-time viewers might know that I actually hate doing things, or I hate to calculate space with respect to in-place algorithm. And the reason is because very rarely do you want things to be in place, because or rather, not that you don't want things to be in place, but just that very rarely do you want someone to change your input variables, right? But in this case, for merge, it makes sense. Like you could conceivably use this API and expect that nums won't change, right? Where you have other functions where even if you sort the input, it's like, well, I gave it, you know, like me as a programmer, I gave this API this array and it has an ordering that maybe I care about, but then you sorted it after you call this function. That's not acceptable, right? Or that's not maybe that's not something that I expect as part of the precondition or postcondition. So that's basically the idea there. Cool. But yeah, but this is gonna be n plus n, because each of these pointers you can kind of see, right? Each pointer gets decremented once, so this is gonna be n plus n times in total. So yeah, that's pretty much all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.